The next method is randomized block design. The corresponding ANOVA table is here. Here source of variations are column treatments, row treatments, remainder or error. Sum of squares as usual, you have to find out SSC, SSR, SSE. Degrees of freedom C minus 1, R minus 1, C minus 1 into R minus 1. For the total degrees of freedom is R into C minus 1. Now the mean square is MSC. MSC value is SSC divided by C minus 1. MSR equal to SSR divided by R minus 1. MSE equal to SSE divided by C minus 1 into R minus 1. Now the problem in your book, page number 1043. So there are three variables A, B, C of a crop are tested in a randomized block design with 4 replications. The plot yields in pounds are as follows. So here they are given this A6, C8, B7, C5, A4, B6. These are the data they have given. They are asked to analyze the experimental yields and state your conclusion. The very first step is you have to assign the null hypothesis. So here variation between varieties do not differ significantly from the variance due to random errors. Similarly, variation between blocks. So these are the two components here. One is variates, another one is block. So the second hypothesis we are taking that variation between blocks do not differ significantly from the variation due to random errors. So in the given data, first you have to arrange it in the form of A, B, C. Each column you have to arrange it in the order A, B, C. Okay, that is the second step. Calculation of sum of squares. The variety, first column you have to take as A, B, C. Then 1, 2, 3, 4. Okay, first column. According to the order A, B, C, you have to write down the values as here. So first value is for A is 6, B is 7 and C is 8. So you have to write here 6, 7, 8. Likewise each column you have to write in the order A, B, C. And then you find out the total as 24, 28, 32 and column wise total is 21, 15, 24, 24. Row wise totals are considered as B1, B2, B3 and column wise totals are considered as B1, B2, B3, B4. Then the correction factor you have to find out T squared by N. That is nothing but T is the total value 84 the whole square divided by N is number of data. So here you are having first row 4 data, second rows 4 data, third row also 4 data you are having. So totally 12 data you are having. So that is N value. So when you are dividing you get 588. Now sum of squares between blocks, that is equal to, this is a formula, B1 square plus B2 square plus B3 square plus B4 square divided by 3. Because you are having that 3 rows here, so you divided by 3 minus correction factor. Okay, B1 is 21, B2 is 15, B3 is 24, B4 is 24 again. You substitute all the values, then you simplify, you get the value is 18. Then sum of squares between varieties. V1 square plus V2 square plus V3 square divided by 4 minus correction factor. So V1, V2, V3 these totals divided by 3 minus correction factor is 588. So you have the value is 18. Next one is sum of squares between varieties. Okay, V1 square. So V1 square plus V2 square plus V3 square divided by 4 minus 1. So that is you are having the value is 8. Then total sum of squares. Each data you have to square and find the sum. 6 squared plus 4 squared plus 8 squared plus 6 squared plus 7 squared, 6 squared plus 6 squared plus 9 squared and so on. Okay, minus correction factor. So you have the value is 36. The next one is residual sum of squares. SST minus SSC plus SSR. Substitute all the values, then you get the value is 10 here. The next one is ANOVA table. ANOVA table source, you substitute all the values here. Okay, then mean square you can find out 18 divided by 3, next one 8 divided by 2, then next one 10 divided by 6. Then you have to find out the ratio. F blocks kuria value is 6 divided by 1.667, so you get 3.6. And the tabulated value is gamma 1 is 3, gamma 2 is 6 at 5% level. F varieties means 4 divided by 1.667. Okay, this 4 divided by 1.667 value is 2.4. Here the tabulated value is 5.14. So gamma 1 equal to 2, gamma 2 equals 6 at 5%. Now the conclusion, you just compare the values as calculated and the tabulated value. Since the value is less than, calculated value is less than the tabulated value, variance between blocks do not differ significantly. Similarly, for the varieties, calculated value is less than the tabulated value, therefore variance between varieties do not differ significantly. Okay, so this is the method regarding to randomized block. Here the only thing is, the very first step you have to write it in the order A, B, C, then you create the table, and as usual previous methods you have to find out the sum of squares between columns, between rows and between errors. Okay, similar to the previous methods.